posted the Mastering Physics code to the class website. So if any of you guys are ready to register through Mastering Physics, the class code is there. Don't forget that this is just the code to link you to the correct class. You still have to buy access to Mastering Physics. Okay? Something else that I noticed was that the link that I had included on the class website to explain how to connect to Mastering Physics and get a 2-week trial period, that video is no longer available on YouTube. It's probably just because it's a couple years old. So I contacted the Pearson rep to get a link to the new video. Okay, so I'll post that at some point. All right, but if you've already purchased your Mastering Physics access, this has nothing to do with you. It's only if you need the 2-week trial period. And don't forget, the first homework assignment isn't going to be due for a couple of weeks anyway. All right, are there any questions before we begin?
Next week, right?
No, so on Tuesday, it's always 1 week after we finish a topic.
Okay.
So on Tuesday, we're supposed to finish vectors.
Okay.
So we're going to do a minimum of 1 week after that date. And then with every homework assignment, there's a 1 week grace period where you can turn in the homework late and not be penalized. So you would have at least a week before it's due after Tuesday, and then at least another week of grace period. So there's still plenty of time. It's always slow to start the semester. Okay, just make sure that you guys do get the code as quickly as you can, mainly for access to the textbook. That's the main thing. Okay? Any questions before we get started? All right, so we're continuing talking about vectors. Don't forget that there are 2 forms of a vector. We have our magnitude and direction form, and we have our component form. And what's important is that a lot of vector algebra is done in component form, so we need to be able to convert between the 2 forms. Okay? That's where we ended last class, was talking about how to take magnitude and direction information and convert it into component information. Okay? I also introduced vector notation, a little bit of notation at the end of last class, so I want to briefly remind us of that. If some quantity is a vector, okay? For instance, velocity is a vector. That's how fast you're going and where you are going. Then it will be given by a variable with the overhead arrow. Okay, so for instance, velocity is v with the arrow overhead. Okay? The magnitude of this vector can be given by 2 forms. You can either write the symbol by itself without the arrow. It's important to remember that the magnitude is just the length of the vector, and the length of the vector is given by a single number. Okay, if you have an arrow pointing in some direction with some length, the direction is described by one number, the length is described by one number. So the magnitude of the vector is a scalar. Okay? Magnitude will either be given by v with no arrow, or it will be explicitly written with like the absolute value bars. Okay, both of these are acceptable ways to describe the magnitude of the velocity vector. Okay? And the components of the vector are denoted, once again, components are scalars, okay? They're described by a single number. They're denoted by taking the letter of the vector without the arrow and putting a little subscript to denote what axis that component runs along. So, for instance, maybe you have an x component and you have a y component. Okay, if we have a regular xy coordinate system, and we have some vector A pointing at some angle theta, that vector can be broken down into its components. One component is how far it extends along the x-axis, and one component is how far it extends along the y-axis. So how far does this vector run along the x-axis? That we would call A, no arrow, with a subscript x. And how far it runs along the y-axis, we would call that A, no arrow, subscript y. And then we could say that the magnitude of this vector to complete this triangle is just A. Okay? Using a regular Cartesian coordinate system, your regular xy coordinate system, the x and the y-axis are always going to be perpendicular, so we form a right triangle here, and that right triangle is going to be the basis for doing these conversions. All right, everything so far has been a summary of what we talked about last time. Okay, let's do one more example of converting from magnitude and direction down to component. Okay, so let's say that this vector A has a magnitude of 10 and a direction of theta equals 47 degrees. Okay? The way to write the conversion from magnitude and direction form into component form is always going to be the same. Okay? It's always going to be the magnitude of your vector times a trig function, either sine or cosine. Okay? The components ax and ay will always be given by the magnitude A times a trig function, either sine or cosine.